Okay, welcome to my video tutorial about Python. This is not a Python course, honestly. This is just I just want to solve some problems that I find interesting using Python, basically because I'm learning Python, even though I just started yesterday. However, okay, I'm not going to make an introduction of this. I just want to go ahead and start with it. Um, okay, so as you see, this algorithm purpose is to find the first 1000 prime numbers, and to do that, I created a list, right? I used to work with MATLAB a long time ago, and in MATLAB it was way easy because in MATLAB you can create arrays without any elements. To be honest, I don't know how to do that in Python because I just started, as I mentioned, I guess yesterday. And well, I just created a list with one single element. As you see here, it's 1. And I'm going to add an element to that list each time that I find a prime number. Okay, to do that, I created a variable called that equals 1, and b is the integer that I'm going to evaluate in order to find a prime number. D indicates whether a quotient is 0. Each time that I find a prime number, I'm going to add 1 unit to D. Basically, D started with 0, but if I find a prime number, I'm going to have a D is going to equal 2. Why is that? That is because let's do it with an example. Let's say that I have 4, right? 4. I'm going to divide 4. I'm sorry. 4 is not a good example. 3, which is a prime number, right? So 3 is divisible. I'm sorry, by 1. Let's just assume that that's a 1. So basically, you have that the quotient here is 0, right? The quotient here is 0, and 3 is only divisible by 2, right? Okay. What's the definition of prime number? Anyways, a prime number is a number that is only divisible by itself and by 1 and itself. So that's why I know that if I that is only divisible by 1 and its own, and that's how I know that if D equals 2, that's a prime number. In any other case, D is not going to be a prime number because let's try with 4. 4 is divisible by 1, is divisible by 2, and is divisible by 4. In that case, anytime that the quotient is anytime that I find a quotient 0, I'm going to add 1 unit to D. And in the case of 4 number, D is going to equal 3, so it's not going to be a prime number. So in this case, the quotient is C, right? As I mentioned, B is the integer that I'm going to evaluate. Basically, this percentage symbol here means that I want to know the quotient of this division B. I want to know the quotient of B divided by I plus 1. Why I plus 1 and not only I? I didn't know this, but in Python, when you use a loop, this little variable here divide always starts with 0. So the first iteration, if I don't add 1 here, it's going to be I don't know, b, which the first iteration is going to be 2, right? B, the quotient between 2 divided by 0, and that's not possible because the division by 0 in mathematics is not defined, it's not possible, so that's basically why I did this. So I use this for build because I want to divide b for all the numbers before b. For instance, if b equals 10, I want to divide b by 1, by 2, by 3, until 10. Basically, that's why I did that. And then, what if I find a prime number? If I find a prime number, then I add that prime number at the end of the list, right? At the end of the list, and that is going to be the case for each every time that I find a prime number. At the end of the loop, well, I have while here. With this, basically, I make sure this is left a. Okay, it's like, what does this while here means? It means keep doing this loop, right? While until length a is like the size of the list, the number of elements of the list, is lower than 1001 elements. So basically that's what it means, and I'm going to tell you why later on. And you're gonna see why I decided here, I type it here 1001 and not 1000. I did that because I have to remove 1. Why? The first element of the list, because you know that 1 is not a prime number, but in this case it is an element on the list. So if I input here 1000 when the size is 1000, the loop is going to stop on the last number. The last prime number is going to be out of the list. I don't want that, and that's why I input. That's why I typed 1001 here, right, instead of 1000, and that's why I decided to remove 1, because 1 is not a prime number. Okay, so I'm going to save this just in case. Okay, tools. I'm going to stop the video here right now. Because this is going to take a while, like 1 minute or something. I don't want that in my video. Also, okay, I'm going to pause the video a while. Okay, now you see that I got a list, and see that I don't have 1 here because I removed it. And okay, let's try this. Okay, no, this is another thing. And if you, yes, I have googled it before making the video, so if you find a list of prime numbers, you will see that everything matches. So you have 2 here, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. And so on. It's just the same list. And that's like the first algorithm that I make in Python. Okay, so in that case, this is my solution. To be honest, this is just a part of a bigger problem that I wanted to make, but I will share that with you later on once I find out how to do it. However, this is my solution. If you have another solution, you can share it with me in the comments. So I would really appreciate it, especially because I know that the creator leaves with one element and start adding elements. That makes um, my algorithm as lower than it should be. And if you know a way that you can create an array or a list with a number of spaces that I just have to fill in instead of adding elements to a list, I would really appreciate it. I don't know how to do it. However, if you know it, please share it with me. I would really appreciate it. And I'll see you in the next video.